Alright, in this lesson we're going to be looking at exponential equations and inequalities, and we're going to solve analytically. Now later on we'll look at graphing them, solving and graphing using appropriate technology. We'll look at that later. Now let's look at our essential question here. From 1998 to 2003, the United States gross national product can be modeled by the function y is equal to 8,882 times 1.04 to the x power. Okay, x is the number of years since 1998. For what years in the period was the gross national product greater than 9 trillion? Okay, so after the lesson, I want you to come back and solve this. Now with this, we just have a couple of vocabulary words. We have exponential equations. Equations with variable expressions occurs as an exponent. So basically, we'll see examples in a second, but if we had, say, 4x is equal to 12 to the 3x, that would be an example of an exponential equation. We have the variable and the exponent. The one before would have been an example. Basically, it just means you have, again, the exponent in the power place, or as far as that goes. Now, inequalities, just kind of some here that can be written in the form like this. Just, greater than 0, less than 0, greater than or equal to 0, less than or equal to 0, and greater than and equal to 0. Now remember, A, still our same rules. A can't be 0, and B can't be 1. And then B has to be greater than 0. Will be that. Now let's look at an example solving these types of equations. Now here we have the same base. Anytime you have the same base, you can put your exponents equal to each other. Now this is one of the more straightforward ones that you'll see. Here you have base of 4, base of 4. Our exponents, okay, then have to be equal. So what we'll do is just set those equal. Negative 2b is equal to 3. Okay, it's just a one-step equation, and so we end up with b is equal to negative 3/2. Alright, now let's look at this example. Now this example, 81 and 27 are not the same base, but we can write them in terms of each other. Remember that 27 is a multiple of 3, so what we can do here is go 3. I know 3 times 3 is 9 times 3 is 27, so 3 to the third power is 27. Okay, so I can write 27 as 3 to the third power using an exponent. Now here we'll bring down the negative 3x. Now 81 would actually be 3 to the fourth power. Now what we're going to have to do is end up multiplying 4 times that, but 3 to the fourth power replaces the 81. Okay, so now what we can do is put 4 times negative 3x is got to equal 3. Okay, so we're writing them in terms of the same base. Now we have the same base. Okay, and then we're going to put our exponents equal to each other and solve for x. There's a couple. I'm going to go ahead and just divide both sides by 4. So we end up with negative 3x is equal to 3/4. Okay, so now we'll end up dividing both sides by negative 3. Okay, I'm dividing a fraction by a whole number. I put this over 1. Flip. So I'm going to end up with 3/4 times 1 over 3, negative. Those will cancel out, and we end up with negative 1/4 for our x value. So that means if I put in negative 1/4 in for x, I would end up with 27. Okay, now in this one, again, we've got to get the same base. I know I can write this in terms of 5. So 5 squared would be 25. Okay, 5 to the third power gives me 125. So I'm going to end up with 3x is equal to 2 when we solve for the x value here. Divide both sides by 3, and so x is equal to 2/3. So the key here again is getting the same base. Now in this example they already have the same base, So we can just put the exponents equal to each other. So we'll end up with m plus 2 is equal to 2m. Okay, for this. Now for this, we got to get our m's together, so I'm going to subtract m from both sides. So we end up with 2 is equal to m. And if we wanted to check it, we could put in 2 for m, and we should end up with the same thing on both sides. So we end up with 5 to the 4th here is equal to 5 to the 4th. Okay, and we could go ahead and take it to the 4th power, but we don't need to. We see that these are equal to each other. Okay, here's another example. Okay, got to get the same base. Okay, I know 4 goes into this and 4 goes into this. So we'll do 4 squared. Okay, we're going to keep the negative n up there. And then we have 4 cubed. So we'll simply do the 2 to the negative n. 2 times negative n is equal to 3. So we end up with negative 2n is equal to 3. Divide both sides by negative 2. And n is equal to negative 3/2. Alright, so let's look at this. In this particular one, we have 4, we have 8 and 4. Okay, we can't get the same base with 4. 4, that may be a temptation, but we can't do that with that. But we can do 2. Because 2 cubed, or 2 times 2 is 4, times 2 is 8. So we can take that and for there. So 2 cubed gives us the 8, and that's equal to 4 to the n minus 1. Okay, so now we can rewrite this as 3 to the negative 2n plus 3 is equal to negative n. Now when we do this, what we can do is go ahead and distribute the 3. But remembering that we got to multiply everything inside here by 3. So we end up with negative 6n plus 9 is equal to negative n. Combine like terms. So I'm going to go ahead and move the n over. So I'm going to go 6n both sides. So we end up with 9 is equal to 5n. Now this is, I have negative n plus 6. So there's different signs. I subtracted to get 5. And then we divide both sides by 5. And we end up with 9/5 is equal to n for this one.